largest element. For finding the largest element, I will take a variable largest and initialize this array of zeroth element, and I will traverse through the whole array, and whenever I find the current element is greater than the largest element, I will update the largest as current element, and simply I will return the largest element. This will take big of L time complexity, and space complexity will be big of n big of 1, because we are not using any extra space, we are just using a single variable largest. Second question is, find the second largest element. So for finding the second largest element, we have two cases. So let's talk. I will initialize I will take two variable, largest and second largest, and I will initialize the largest as array of zeroth element and second largest as -1. Then I will traverse through the array, and whenever I find the current element is greater than the largest element, I will update the largest element as current element. Then I will update the second largest element as largest. And second case is, whenever I find the current element is greater than the second largest element, as well as the current element is less than the largest element, at that time I will update the second largest element as array of I, and simply I will return the second largest. The time complexity is big of n, and space complexity will be big of 1, because we are using couples of variables, not using any extra space. Coming to the third question, check the array is sorted or rotated. We have to check. So logic is, I will traverse through the array and I will find if the current element is greater than the next element, then I will update the counter, and I will check if the counter is greater than the 1, then it is not sorted and rotated. If this counter is less than equal to 1, then it will be sorted and rotated. And this will take big of n time complexity, and space complexity will be big of 1, because we are not using any extra space. We are just using couples of variable, not couples, only one variable count. Third problem is, remove duplicate from sorted array. Remove duplicate element from sorted array. So the optimal approach is I will traverse through the array from the index 1, and I will check if the current element is not equal to previous element, means this is my unique number. So I will store into the nums only, array only. Okay, this is not correct way to explain. So I'm using two pointer, first k and I initialize k as 1, because first element is always unique, that's why. So now I am traversing through the array, and whenever I find the current element is not equal to the previous element, means that current element will be my unique element. So I will store in nums as the current element, and I will update the k, and simply I will return the k, and this will take big of n time complexity, and space complexity will be big of 1 because we are not using any extra array. I am updating the value in given array itself. Now coming to the next question. Left rotate an array by once, but this is like different question. We have to find rotate array by k times. I have to find rotate the array by k times. So for that I will use reverse algorithm, and first of all I will reverse the whole array, then I will reverse the array till kth step, then finally I will reverse the remaining part, that is n minus k, and this will take big of n time complexity, and space complexity will be big of 1 because we are reversing in given array itself, so space complexity will be big of 1. Now next question is move 0 to end. Move 0 to end. So the brute force approach is I will take a array list and I will traverse through the array, and whenever I find the I will take one array and I will traverse through the whole array, and whenever find the current element is not equal to 0, I will add in the element into the array, and then again no, this is wrong. Here this must be list. I am using list, and I will traverse through the array, and whenever I find the current element is not equal to 0, I will add the element into the list, then I will traverse through the list and I will make the given array itself is equal to the list of ith element, and then again I will run a loop from list size till nth, and I will make all element as 0. So this will take big of n time complexity, and space complexity will be big of 1 because we are not using any extra array. I am updating the element in given array itself. So coming to the optimal solution. By the way, there is no better solution for this question. So coming to the optimal solution. So I will use two pointer k and I, and I will initialize the k as 0, and I will traverse through the array, and whenever I find the current element is not equal to 0, I will update the array of kth index as array of current element, and at that time only I will check if I is not equal to k, I will make the current element as 0, else I will update the k. So this will be my optimal solution. This is my optimal solution, and this will take big of n time complexity, and space complexity will be big of 1 because I am not using any extra array. I am updating the element in given array itself. The next question is very simple. Linear search. I think I don't have to like explain. This is very easy question. So we have given an array and one target. So Simply I will traverse the array, and whenever I find the current element is target is equal to target, I will return the index I, else I will return the index -1. But this will take big of n time complexity, and space complexity will be big of 1 because I'm not using any extra space. So if we talk about optimal approach, so yeah, I can apply binary search here. That will be that will take big of n log n time complexity. So I will talk into the binary search video. Let's leave. Now question is find the union. This is also very simple question. Uh, I will use tree set. As you can see here, I am using tree set to store the both the array element. So I will use tree set, and I will traverse through the both array, and I will insert the element into the set. Then I will create a new array of result, and I will copy all the set element into the my new result array, and simply I will return that result. This will take big of n log n time complexity, and space complexity will be big of 1 because I am using here new array. So yeah, space complexity will be big of n. Now the next question is find missing number in array. Find missing number in array. So I have two approach. I can solve using cyclic sort, and I can use using like simple mathematics concept. So if I talk about simple mathematics, then uh, I'll find the sum till the given range, means I will find the sum. Okay, let me think. Actually I forgot. हमको फाइंड करना है सम अरे के साइज के बराबर. Okay, now I got it. So n is the size of the array, and I will find the sum of array 1 till nth. It's just index only. Then I will initialize sum to as 0, and I will traverse through the whole array, and I will add the all element into the array, and simply I will minus the sum 1 minus sum 2. I will do that will be my missing number. Or I can use cyclic sort. By the way, like both are taking same time complexity and space complexity. This approach is taking big of n time complexity, and space complexity will be big of n because I am not using any extra space. Okay, so this is cyclic sort. Okay, next video I will talk about cyclic sort. So